Good morning. Today we are going to learn a little bit about basic constructions. You're going to need your compass, protractor, probably a ruler if it's a really small one. This set of notes is designed to go with the first section of chapter 1, as well as the first homework, which is a game and some geometry. If you do not have the notes printed out, you will need to write in the typed words. And so you can stop the video at any time to fill those in because it does go a little slower if you're not actually filling in the blank. All right, let's start with some basic drawing and construction vocabulary. When something says sketch, a sketch is what we call a freehand draw a shape or figure. So you don't have to use a ruler, you can just draw. The word draw, when it's used in your textbook, means you use a ruler, and sometimes we call rulers a straight edge in geometry because originally they didn't have inches and centimeters, they just simply used a very straight piece of most likely wood. So we used to say straight edge because we very rarely use the measurement marks. If your text says construct, that means you're going to use a straight edge or a ruler, your compass, and your protractor. If it says to graph, you're going to use graph paper, and you're going to use a ruler to draw the lines. So we hold the word graph to a very high standard. The axes on your graph need to be bigger than a 3-inch by 3-inch post-it. This is a 3-inch by 3-inch post-it. If I can put a post-it over your graph and cover it up, it's too small. So that's the minimum size. A ruler or straight edge are used to draw any lines in a graph. We label critical points. Critical points means important points in the graph, like intercepts, vertices, turning points, that kind of thing. The scale of your graph, if it goes by ones, you don't have to label it specially. But if you're going to go by 2s or 4s or 5s, then you actually need to fill in the graph scale specifically. All right, so let's get into some constructions along with some basic vocabulary. First thing we're going to do is draw a line AB. Okay, so using your straight edge or your ruler, we're going to come down here to the bottom, and we're going to draw a line. Now, a line actually goes on forever. So when it says line, it gets arrowheads to show that. If it says to draw line AB, A and B are points on that line. So we're going to draw A, and we're going to draw B. And for B, we're going to draw it right in the middle, and we'll talk about that in a second. So that would be line AB. You can say line AB. You can say line BA. Normally what we do is we write AB and we put a line above it, just like that. And again, you can reverse the points for the name. You can say the word line and then AB. We also have the option to label lines using italicized labels. So oftentimes you'll see something like line, and because an L looks like a 1, we typically use cursive on our work to show italicized. And then that italicized name appears at one of the ends of the arrowhead. All right, we're going to mark point D so that it is between points A and B. So we're just going to mark it now. It doesn't necessarily mean it's any closer or further away. It just means it's in between. So it could be here, it could be slightly to the right or slightly to the left. But that is the word between. All right, definition, collinear. 2 points are collinear. Points A, B, and D are collinear, which means they are on the same line. So these 3 are collinear. So now we're going to mark point E so that it is equidistant to B as point D is to point B. This is where your compass is going to come in handy. So put your stylus, that's the pointy part, on B. Adjust your compass so that the pencil is on B. So that's the distance they are away. So to measure the same distance on the other side of B, you just rotate and draw a little line. And it shouldn't have a changed setting. So this distance and this distance are the same. So we're going to draw E so that it is equidistant to B as D is to B. So this little point here is going to be E. And because we used our compass, we know that DB and BE are the same. This is how we mark similar lengths in geometry. The hatch marks tell you which ones have the same length. This is a single hatch mark, so DB is equal to BE. Okay, equidistant. The word equidistant is the measure between two objects is the same as the measure between two other objects. That is the definition of equidistant. So D and E are equidistant to B. All right, flip page. Okay, moving on with our constructions. We're going to construct a triangle ABC with two equal sides. We're going to use our compass. So to construct a triangle, we've got A and B. C is the third vertex in the triangle. So put your stylus on A, open up your pencil a little further, and we're going to draw a line here. Anywhere on that line, A is the same distance. See how the compass is the same? So anywhere on that line is the same distance to A. So without changing the setting, lift the stylus to B, keeping the length the same, and draw another arc. I'm sorry, this is a little bit hard to see. Pencil always is. So the distance from B to this arc is the same everywhere on the arc. So it makes sense that wherever those arcs meet is equidistant to B and A. So this intersection point right here, we're going to call C. We're going to use our straight edge and finish our triangle. And we were supposed to make a triangle with two equal sides. Well, AC and CB are equal lengths, so we're going to mark that. So that's how you draw a triangle with equal sides. You can use 1, 2, or 3 hatch marks to indicate equal lengths. All right, this is just like the front of the packet. A dog and his owner are standing 110 feet apart. We assume that 1 centimeter is 10 feet. If the owner can throw the disc 70 feet and the dog runs 60 feet to catch it, show where it will be caught by the dog. And then we'll do the second part in a second. Okay, so the owner can throw the disc 70 feet. So if I use my ruler, find the centimeter setting, 1 centimeter is a foot. So 70 feet, or sorry, 1 centimeter is 10 feet. So 70 would be to the 7, so 0 to 7. And I'm going to use the end of the arrow as my marking point. So that is 70 feet. So if he throws the disc 70 feet, it will land somewhere on this arc. 70 feet. Now the dog can only run 60 feet. So again, use your ruler, put the stylus on 0. 60 feet is 6 centimeters. So there we go, that's your 60 feet. And I'm going to use the arrowhead as my center point. So we're going to go 60 feet. Oops, I got to readjust. It moved. So if I measure 60 feet, we have a problem because this arc is everywhere that the dog could run 60 feet. So at 60 feet, he wouldn't catch the frisbee. He can't go far enough. See, those arcs don't intersect anywhere. So where will be caught by dog then? The dog can't catch the disk at 60 feet. All right, so we're going to adjust this a little bit. We're going to change this question. Let's say that the dog runs 80 feet. Okay, so measure 8 centimeters or 80 feet using your ruler. There we go. We're going to mark a new arc for the dog. He runs further now. He's going to run 80 feet. So here is the arc for 80 feet. So everywhere on this arc, the dog will run 80 feet. So the question is, if the dog's running 80 feet and the disc goes 70 feet, where can the dog catch the disc? Well, I'm going to mark this really quick, just to be clear. Which arc? This arc is your 80-foot arc. Well, your 80-foot arc and your 70-foot arcs meets up right here. So that is one place that the dog can catch the Frisbee. I draw a line from the dog to that mark. It is 80 feet. If I draw a line from the man to the mark, the disc was thrown 70 feet. So that's one location. But we also have a second location, which is down here. This point down here is also on the same arc for the dog. So from here to here is 80 feet for the dog. And this point is also on the arc for the disc thrower. From here to here is 70 feet. So there are actually two places that the dog can catch the Frisbee. So the last one says, how many directions can the disc be thrown so that the dog catches it? The answer to that second question is 2 places. And that would be the work to show it. This is a lot like what you're going to do on page 1 of your worksheet. All right, let's get back into some vocabulary. Names for a plane. Okay, how can you name a plane? You can name a plane with the word plane, and planes are named with capital letters. So plane, capital M, is one way you can name it. You can name it with the word plane, and you can pick 3 points on the plane in any order. So like plane ABC or plane CBA. There's lots of ways to label the plane. Typically, if they're going to do a 1-letter name, it's going to be in the corner of the plane, not in the middle. When you draw a plane, it's shown like a parallelogram, slanted up and to the right. The opposite sides of a plane, when you draw it, are congruent. The word congruent in geometry means the same length. We have a nifty symbol for congruent. It's an equal sign with a backwards S or a Spanish tilde. So you never have to actually write the word congruent. Okay, so let me show you how you construct a plane. So typically you want to go to the bottom left of your space and draw maybe a 2-inch segment. And then we don't typically measure the angle, so take your 2 inches, go straight up and go to the right a little ways, keeping it parallel. Draw another 2 inches. When you join the left sides, it should be parallel to where you join the right sides. So this is the plane drawn up and to the right. We're going to call this plane M, so I'm going to put a capital M here. So it says construct a perpendicular segment, ED, also written segment ED or DE. A segment has endpoints. So you'll notice it's got a line on top, but no arrowheads because segments don't go on forever. So the way you draw a perpendicular segment is you draw the point where it hits, we'll call that D, and then using your ruler, you go straight up, dashed line, and then the other end point of the segment is E, because it's E to D, so we're going to put an E here. The symbol for perpendicular in geometry is a little half box that says 90 degrees. So that's how you draw a segment perpendicular to a plane. All right, now we're going to construct a line N intersecting plane M at one point. All right, so basically if it's intersecting a plane, it's punching through it. So you take your ruler, mark where you want it to punch through. Where you can see it on top of the plane, it's a solid line. Where it's behind the plane, you use a dashed line, and then where it sticks out again, you go to solid. And it's a line, so it gets arrowheads. This is line N, so N is a cursive N at one of the ends because it's italicized. This is a line intersecting plane M at one point. All right, definition coplanar. Points are coplanar if they are in the same plane. It says points A, B, and E. Okay, so let's draw this. If this is plane ABC, that means that point A, point B, and point C must be somewhere on the plane. Otherwise, we couldn't name the plane ABC. ABC are coplanar because they're in the same plane. Now, ABC, or sorry, AB and E, so this one, and this one, are also coplanar because there could be a plane containing them. And you can draw a plane through any 3 points. Okay, let's do another construction. Get your compass handy. We are going to construct circle C. And the definition of a circle is the set of all points equidistant from a center point. Equidistant means equally distant. Circles are named by their center point, which is capitalized. So we would say circle capital C, and C would be the center. You can also draw a circle, put a dot in the middle, and then put the capital C after, which is a great symbol to know. So the way you make construct a circle, so I want you to adjust your compass so that it's not going to go off the paper. You set the point down in the center, and sometimes people pre-draw it. They'll say, okay, this is going to be center C. Sometimes they do it afterwards. Put the stylus in and gently draw a circle around that point without lifting the stylus. You might have to lean it over a little bit. That is a perfect circle, and it's circle C. And pause this if you need to, and I'm going to go on. Mark congruent segments A, C, and CB. Okay, so remember a circle, it's equidistant from the center to any point on the edge. So I can draw point A here, and its distance to the center will be the same as any other point I put on the circle. So I can put the point B over here, and C to B will be the exact same length. So CA and CB are congruent to each other. Let's write that. CA is congruent to, put the segment on it, CB. It means they're the same length. All right, last construction we're going to learn. Flip the page. We're going to construct a segment bisector, also called a perpendicular bisector. And it's not too bad. What we're going to do is we have a segment here, and we're going to find the midpoint. We're going to call it M, and then we're going to do some of the other stuff. So how do you find the midpoint or the segment bisector? Bisects means cuts in half. The midpoint tells you where the bisection happens. So the way you do it is put your stylus on A and then adjust your pencil anywhere that's more than halfway. You can eyeball that, and then you draw a half circle. Then, without changing your setting, lift the stylus, put it on B, and draw the identical same size of half circle from point B. what you'll see is that the two arcs will intersect each other. So take your straight edge and line it up with the top intersection and the bottom intersection. And we're going to draw a line. Okay, the place where the line crosses AB is the midpoint. So this is your midpoint, which means that AM and BM are the same. So we're going to write that. Now, there's a little bit of notation here. If you're writing that the distances are the same, equidistant, these segments lose the bar. So it's just AM, no bar, equal to BM, no bar. That notation means you're talking about the length. The lengths are equal. When you're talking length, there's no bar. Anything else, you put the bar up. If you say that they are congruent, congruency means they have the same size and shape. In the case of segments, if the segments have equal lengths, they're automatically congruent, but you write it differently. You say segment AM with the bar congruent to segment MB or BM with the bar. And so you can see how these mean different things. Congruency is a bigger title, means size and shape. All right, so let's label this a little bit. M on this drawing is the midpoint. The line that you constructed is actually perpendicular, so we can put a box on it. Because it is perpendicular and it's on the midpoint, we know that this line, and we're going to label it, let's put letter P on this. So we have MP. We can say that line MP, put the line on there, is the perpendicular, that means 90 degrees because this is 90 in there, perpendicular bisector because it crosses the midpoint of segment AB. You can't say line AB because lines go on forever. The symbol for perpendicular is an upside down capital P. So we could write MP, which is a line, perpendicular to AB. We know that the lengths are equal, so AM equals BM. Now, there's something else about a perpendicular bisector you need to know. If I pick any point on that perpendicular bisector and I draw a line segment to A and to B, from this point, I'll call it N, to the end points will always be the same length. It'll always match. And it doesn't matter if I draw N here or I can draw N down here. The distance from N to the end points will always be the same length. That's going to change lengths, but it's going to be the same. And AB are endpoints. All right, so based on that, how many points on the bisector are equidistant from both ends? And we just marked 2 places that are equidistant. So how many points will be equidistant to both ends? There will be infinitely many points. And there's a symbol for infinite. It looks like a sideways flattened out 8. That means infinite. So infinitely many points are going to be equidistant to the endpoints. Okay, that is the end of the notes. I hope you got a lot out of the constructions and can use what we just learned on the packet. Have a good morning.